The Venn diagram shows the sets P and Q contained in the universal set. List the elements in the set P union Q. So first, let's list off the elements that are inside P. So the elements that are inside P are T, Y, W, and A. Again, T, Y, W, and A. These are all part of this big set, right? This big set P, all right? So the elements that are inside set P are going to be T, Y, W, and A. Now, what are the elements inside Q? Well, the elements inside Q are going to be W and A. So the elements inside this small circle right here is going to be W and A. These are the elements that are inside W and A. Now, this particular situation that we have is we have a subset. So Q is a subset of P because all of the elements in Q are also inside of P as well. And so that's what we mean by a subset. So the elements that all of the elements inside Q are also inside of set P, okay? Now, they're asking us for the union. So the union is all of these elements combined, but no repeats. And so the union is going to be T, Y, W, and A, right? Because P, T, Y, W, and A is inside P, and W and A is inside Q. And so we have to list all of those together, but no repeats. And so it's going to be T, Y, W, and A. And so the union is going to be, the union of P and Q is going to be T, Y, W, and A. And that's the correct answer for this one. Next, the question says, list the elements in the set P intersect Q. Now, P intersect Q is going to be all of the elements that are in P and Q combined. And so we list the elements of P, which is T, Y, W, and A. We list the elements of Q, which is W and A. And the ones that are the same are going to be W and A. And so the intersection of P and Q is W and A. And that's the intersection. P intersect Q is the set WA. Next, the question says, we want to list the elements in the set Q complement. Now, Q complement, right, means that we want to include all of the elements that are inside the universal set, except for the elements that are inside Q. So that means that we do not include any of the elements that are inside Q inside of this listing. All right, so we include all of the other elements inside the universal set, but we do not include any of the elements inside Q. So we have T, Y, X, S, and Z. All of these elements are inside Q complement. These are in the universal set, but they are not a part of set Q. And so our answer is going to be X, S, Z, T, and Y. And these are the elements in Q complement. Next, the question says that we want to write down the value of N, open bracket, P, close bracket. Now, what this actually means is the number of elements in set P. Now, the number of elements in set P are the following. So this is one element in set P, there's another element in set P, there's another element in set P, there's another element in set P. So these elements, right, 4 of them are inside set P, all right? And even though these 2 elements are inside set Q, they are also part of set P, right? Because Q is a subset of P, which means that all of the elements inside set Q are also part of set P as well. And so we have T, Y, W, and A. So that means that the number of elements in set P is going to be 4. Next, the question says, write down the value of the number of elements in P complement intersect Q complement. So we want a number of elements in P complement intersect Q complement. What does that mean? Let's first list off the elements in P complement. Now, what do we mean by P complement? P complement means all of the elements that are inside the universal set, but we do not include any of the elements inside set P. Notice that set P is all of this. So all of this is set P. Okay, note all of this is set P. We do not include these elements in our listing. You cannot include them. But all the other ones you can include. So X, S, and Z, these are the elements that are inside the universal set, but they are not part of set P. And so they're going to be a part of P complement. Now, so we have P complement. Now we need to determine what is Q complement. Now, what is Q complement? Q complement is going to be everything inside the universal set except for Q. So we do not include W and A. We cannot include any of the elements that are inside set Q, right? We do not include them, right? So that means that all we have is X, S, right? C, T, and Y. These are the elements that are inside Q complement, okay? And so we know what are the elements inside P complement. We know what are the elements inside Q complement. But they want us to find out what is the intersection between them, right? So what is the intersection? The intersection is what's inside both of these sets. And so we have X is inside both of them, S is inside both of them, and Z is inside both of them. So these three elements right here are part of P complement intersect Q complement. So P complement intersect Q complement is X, S, and Z. But the question asks us to determine the number of elements, how many elements are inside the set. As we can see, there are only 3 elements, 1, 2, 3. And so that means that the number of elements in P complement intersect Q complement is 3. Again, the number of elements in P complement intersect Q complement is 3.